Welcome back, guys. I want to do a couple examples with you so you're able to do the homework for this section. All right, so a car traveling 5 meters per second across the table is going to fall off. If the table is 1 meter high, how long until the cart reaches the ground? How far from the table does it land? So very common horizontal launch problem. And again, AP Physics likes to focus on things that are misconceptions. And a misconception is that if I throw something and drop it, they would hit the ground at different times. That's not the case. All right, so I'm going to plug in what I know. And I know that my cart is going at 5. So that's in the X direction. I also know that in the Y direction, it's not going at all. There's no velocity in the Y direction. I also know that my acceleration is 0 in the X direction. And so that means my final velocity is going to be the same. I know my acceleration in the Y direction is -10. And I know that this cart is going to start at the top of a table that's 1 meter high and go down to the ground. So the displacement in the Y direction is going to be -1. The final thing I know is that the time for both of these charts are the same. So looking at the Y direction, I'm going to get my time. So I have x minus x naught equals v naught t plus 1/2 at squared. It turns out that v naught is equal to 0. So this is just x minus x naught equals 1/2 at squared. And now it's just a matter of getting t by itself. These negatives are going to be important because we're going to have a square root involved. So I'm going to multiply by 2 and divide by a and square root it. So I have 2 x minus x naught over a. And I'm going to do a substitution with units. And this is going to end up being plus or minus 0.45 seconds. I'm going to pick plus because it's a positive time. That's going to go here. Now, these charts share the same time because it's the same cart. So this is going to be 0.45 as well. And now, if I look at the X direction, in the X direction, the acceleration is 0. So that cancels out. So I just have v naught t. And so that's going to be 5 times 0.45. Which I believe is 2.25, but I will put it in my calculator. So this is my horizontal displacement. All right, another example. Now we're shooting a cannon. So this was what Galileo was supposedly to have done, was to shoot a cannon and drop something out of a tower. So I'm shooting a cannon horizontally with a velocity of 40 meters per second. So this is going to be my initial velocity in the X direction from a 60 meter high cliff. This is going to be my displacement in the Y direction. So those are our two givens. Again, plugging these in, I know that my initial velocity is 40, which means my final velocity is 40, which means my acceleration is 0. If it's all in the X direction, my y direction velocity starts off being 0. My acceleration is -10, and the displacement in the y direction is -60. Again, I'm going to use the y direction to solve for my time. And that part cancels out. And I substitute. So I have a vertical displacement of -60. I have acceleration of -10. So I'm going to have the square root of 12, which is 3.46, or I'll just say 3.5. I'll plug this into my chart. And it goes into the other side as well. And then in the x direction, using the same equation, acceleration 0, so the 1/2 at squared cancels out. And so we have 40 meters per second times 3.5 seconds. And again, I rounded, but the acceleration is not exactly -10 either. So that ends up being 140. A ball rolls at the speed of 2 meters per second across a level table that's 1 meter above the floor. Upon reaching the edge of the table, it follows a parabolic path to the floor. How far along the floor is the landing spot from the table? And you guys, they're giving you the answer. So I'm going to give you guys a couple minutes to see if you can solve this, and then I'll have my solution afterwards. All right, I'm back. And you can see that I filled in the chart for the x direction with an initial velocity of 2, a final velocity of 2. I filled in a chart in a y direction with the initial velocity of 0, an acceleration of -10, and a displacement of -1. I used my y direction to solve for my time, which is 0.45 seconds. And then that was the same time for the x direction. And so I did get the same answer as they gave us at the end of the problem. All right, next one. A rescue pilot drops a survival kit while her plane flying at an altitude of 2,000 meters with a forward velocity of 100 meters per second. If air friction is disregarded, how far in advance of the starving explorer's drop zone should she release the package? So again, this is going to be horizontal launch as well. I'll pause to see if you're able to solve it. All right, as you can see, this one was a little bit different. So we want to know how far ahead they'd have to drop it. So I want to know how long the package is going to be in the air. I use my y direction chart with an initial velocity of 0, an acceleration of -10, a displacement of -2,000, and a time I solved for. So I found out the package would be in the air for 20 seconds. So the question is, how far would it travel sideways in 20 seconds? Because they would have to let go of it before that, so the package would land where they wanted. And so in the x direction, since the acceleration is 0, I have 100 meters per second and 20 seconds. So you'd have to drop it 2,000 meters ahead. A rifle is fired horizontally and travels 200 meters. The rifle barrel is 1.9 meters from the ground. What speed must the bullet have been traveling at? Ignore air friction. So this one's going to be a little bit different. Let's see if you can get the initial velocity in the x direction. Okay, so in this one, we're not given the velocity in the x direction. We need that, but they're telling us how far the bullet goes sideways. It goes 200 meters sideways. In the y direction, I know that it's going to fall negative 1.9 meters, and the acceleration is going to be negative 10. And since it's fired only horizontally, it has no vertical velocity. So again, I used my equation. My x minus x naught equals v naught t plus 1/2 at squared. I solve for t. I got 0.62 seconds. I plugged that in my chart for the y direction and the x direction. And then in the x direction, I did x minus x naught equals v naught t because there is no acceleration. Remember, this is 0. And when I move this around, I get that v naught is x minus x naught over t. So that's 200 meters divided by 0.62 seconds, which is 323 meters per second. All right, we're going to do one last example that's a little bit different. An astronaut stands on the edge of a lunar crater and throws a half-eaten Twinkie horizontally with a velocity of 5 meters per second. The floor of the crater is 100 meters below the astronaut. What horizontal distance will the Twinkie travel before hitting the floor of the crater? The acceleration of gravity on the moon is 1/6 that of the Earth. All right, so this is very similar to the ones we did. The only difference is now we have an acceleration that's not negative 10. It's 1/6 of negative 10. So in the y direction, I have negative 10 divided by 6 for being my acceleration. And so when I plug this in for my time, I have negative 10 over 6 at the bottom of my fraction as opposed to just negative 10. That means this Twinkie is going to be in the air for 11 seconds. And then when I put 11 seconds in my chart here, I can put it in my chart over here, and then I can get my displacement in the x direction because I know the initial velocity. I solve for the time, and the acceleration is 0.